Hey guys, today we're going to talk about proof strategies, and this is going to just be a few things to help you when confronted with a proof on your own, and hopefully a couple of things to keep in mind as you do proofs, maybe to help you along. So I've got three strategies here. The first is to be mindful of the main connective. So every sentence that's has more than one logical connective um, can be kind of confusing when you look at it. So there's this thing that we call sort of the main connective of the argument, or excuse me, of the sentence that will give you a sense, like once you figure it out, will give you a sense of sort of which rules will actually sort of work on it. So the main connective is the one whose scope is the sort of entire sentence. So some connectives only affect sort of a part of the sentence, whereas the main connective would affect the entire sentence. So it tells you what kind of sentence you're dealing with, um, and of course different rules apply to different types of sentences. So this is important. It's important to know which thing is the main connective. And then one way to think about the main connective, or one way to figure out which one it is if you're doing a truth table computation, this would be the connective that you do last. So, for instance, if you are looking at a sentence that has sort of parentheses, you always do the computation within parentheses sort of first. So that would tell you that that connective is not the main connective, right? Because that just deals with the stuff inside the parentheses, whereas the main connective will be outside of those parentheses. So that would be the one that you would do later or last, and thus is the one with the most scope. Um, so let's talk a little bit about binary main connectives, like conjunctions and disjunctions and conditionals. Here are a number of sentences that have a binary as the main connective, but you see that there's a bunch of negations here. That if you were doing your truth table computations, you would have to do those first, because in these kinds of situations, negations go first. So the negations have the more limited scope. So these negations only negate the immediately sort of following letter. So for instance, I'll just draw on this here. These negations only work on A, this negation only works on B, and similarly over here, right, it only works on B, only works on A, so the scope is limited, whereas the binaries have an effect on the entire sentence. So the main connective for all these is the binary, and so you should sort of, if you're looking at these sentences, you should think of them as fitting this pattern. So P and Q for the first, where not A is the P, not B is the Q, P arrow Q for the second, A is the P, not B is the Q, and then P or Q for the third. Um, Here's some situations where you have even more complicated things going on. We've added some parentheses to these sentences, and these sentences will probably be sort of the most complicated that you could expect to see on an exam. But nevertheless, sort of the same thing is going on, that the binary uh, outside of the parentheses is the main connective. So in this case, where's my The conditional here would be the main connective because the or in here is inside parentheses. The or here is the main connective because uh, the arrow here is inside parentheses, and finally the and over here would be the main connective because the or is in parentheses. So again, the binary outside of parentheses is the main connective. And so you should think about these sentences as just kind of following more or less this pattern, right? P arrow Q for the first, P or Q for the second, and P and Q for the third. Okay, moving on. Sometimes negation is the main connective. So again, there's a lot of patterns where you have a negated letter like modus tollens or disjunctive syllogism. Um, so that would be sort of a situation is if we're talking about a complicated sentence would be where everything is sort of inside parentheses except for the negation. So in situations like this, here's some complicated sentences that again kind of represent the most complicated sentences that you could expect to find on a exam. You've got not the case that in parentheses A and B, not the case that not A arrow B, and then not the case that A or B and C. So everything except for the negation is inside the parentheses. So the negation here is the main connective. These should just be sort of understood in terms of patterns as negations. So we should just sort of end here with this first strategy is that sometimes the main connective is just really not going to be important. There are some situations where you should understand a complicated sentence just as a P. And I just want to give an example of this, or a couple examples of this. Here, in terms of patterns, we're talking about modus ponens, and if you'll recall, the modus ponens pattern is P, I'll just draw it here, P arrow Q, P, therefore Q. In both of these examples, the P of this pattern is a complex sentence. So here in example 1, not A is playing the role of P. Here in example 2, A or B is playing the role of P. So despite the fact that both of these actually have a main connective, so number 2 is the main connective is the negation. Excuse me, number 1, the main connective is a negation. Number 2 is the main connective is a disjunction. They, because of the role that it's playing, should really just be understood as a simple sentence. So that happens sometimes too, and it's something to keep in mind. Okay, moving on. The second strategy is just to familiarize yourself with the rules. We are dealing primarily with 7 rules of inference, and really just sort of 6 are the sort of the most common. And so what we're going to talk about is modus ponens, modus tollens, disjunctive syllogism, and then excuse me, simplification, conjunction, and addition. So first kind of set of rules are the rules that sort of break things apart. Simplification is the most obvious of these rules. You take any conjunction and break it apart into its component parts. One thing about this rule that's sort of different from the other rules is that it doesn't require another line to help. So you just take any conjunction, use simplification, and break it apart. Sort of a sub part of this strategy would be that, like, anytime you see a conjunction, you should simplify it. Just if the proof has a conjunction as a main connective at any point, then you should probably simplify it, because chances are that's going to come into the mix. So here's an example just of conjunction, just to kind of show you that you don't need any other line, right? So you have a conjunction here where and is the main connective. So again, this should be understood as P and Q. Here's P, here's Q. Without any other line, you can just sort of break those apart into their component parts. So you see that a lot in at least the proofs that I give you, and so it should be just sort of an automatic step. So, excuse me. Some other things here that we want to keep in mind then is that modus ponens, modus tollens, and disjunctive syllogism also break things apart, but unlike simplification, they require another line to work. So modus ponens, modus tollens break apart conditionals. Modus ponens requires the antecedent of the conditional, and it gets you the consequent. So again, conditionals, if you'll recall, are the arrow sentences. So if you have P arrow Q, then modus ponens requires the antecedent, right? You need the P, and it gets you the consequent, right? It gets you the Q. Modus tollens requires the negation of the antecedent. So you need, as a line, you need the not Q, and that will get you the negation of the antecedent. That'll get you the not P. Okay, moving on. Disjunctive syllogism breaks apart disjunctions, so P or Q instead of P and Q. And this is the argument by elimination. Disjunctive syllogism requires the negation of one of its disjuncts, and then it gets you the other. So if you have P or Q, and you end up with not P, well, that will get you Q. If you end up with not Q, that will get you P. So here's some examples. Modus ponens. There's the pattern, but here's an example where you have a sentence that is a conditional. P and Q are not A, arrow not B. So if you have the antecedent, that will get you the consequent. Despite the fact that these are negations. So remember, the main connective here is the arrow. So this should be understood as just P or Q. Excuse me, P arrow Q. Similarly with modus tollens, here's the pattern. If you have the negation of the consequent, that will get you the negation of the antecedent. So here's a conditional. You have the negation of the consequent here, which is not C, and then you get the negation of the antecedent, which is not the case at A or B. And then finally, disjunctive syllogism, argument by elimination. If you have a disjunction and you have the negation of one, well, that will get you the other. So argument by elimination. So here's a really complicated one, but the main connective is the or, right there in the middle. And so this should be understood as P or Q. And in this case, we have the negation of P. So what that allows us to get is Q. So there's the three rules then that sort of break things apart. So again, just to summarize here, simplification breaks apart conditionals, and you don't require a second line to do anything. You can just break them apart right away. Whereas modus ponens, modus tollens, and disjunctive syllogism, they all require a second line. They all require something to help break them apart. So moving on, there are another set of rules that instead of breaking things apart, build things up. So those are conjunction and addition, and these, in my opinion, are the easier of the two strategies. But conjunction just takes any two lines and puts them together with an and symbol, a conjunction. And addition allows you to add any sentence to a line as long as you do it with a disjunction, right? So or something, or something, or add it to any line, and any level of complexity. So here's an example of conjunction. We've got line 1, which is this somewhat complicated sentence. We have line 2, which is also kind of complex. But you can take those two sentences and put them together with the conjunction rule. So you make an even more complicated sentence. The addition rule is also sort of makes more complicated sentences, and here I have an example of two addition moves. So line 1 is just not A. With line 2, I've added not B to it for no particular reason. There's no strategy here. This is just an example of things that you can add to each other. So I've added a negation to the first sentence and got the second sentence, and then I added to the second sentence C arrow D with another use of the rule. So again, just kind of building things up to more sort of complicated levels by the use of addition, and just bear in mind that addition, it can be anything. So it's very open-ended. Okay, so the last strategy I want to talk about is sort of working backwards. This is, once you get sort of a sense of what the rules are and what the main connectives of your sentences are, this is kind of where you want to be. So when you're beginning a proof, you should always look at the conclusion first. That should give you a sense of what you need to do in order to achieve your goal. Because remember, the conclusion of the argument is the goal of the proof. So it's always the case that the last line of your proof is the conclusion. So the first thing you should ask yourself when you look at the conclusion is, what kind of sentence is it? What is the main connective? And this will kind of help you with sort of working backwards. So once you kind of look at the kind of sentences it is, then you will, the next thing to do is to look at the premises and to see sort of where the conclusion is in the premises. So maybe the entire conclusion could be found somewhere in the premises, or maybe the parts of the conclusion could be found in the premises. And we'll look at some examples here to show you how that works. But that's definitely something that you'll want to think about. And then after you do this, you're going to try to come up with the sort of the end steps of the proof. So I've written up here sort of 4 possibilities. If the conclusion is relatively simple, like just a sentence letter or a negation, the final step will probably be breaking something apart. You'll be taking a sentence that has the conclusion in it and using either simplification, modus ponens, modus tollens, or destructive syllogism, and using that as your sort of final step. The other possibilities are the sentence is more complicated. So, for instance, if your conclusion is a conjunction, it's probably the case that you'll be using a conjunction to at the very end, right? So you'll be taking, two lines, the two pieces of that conjunction, and putting them together. If the conclusion is a disjunction, the final step will probably be addition, right? Chances are that if it's a disjunction, one of the conjuncts doesn't appear anywhere in the proof, and you'll just have to sort of add it at the end. And then finally, here's a rule that we haven't really talked about much yet, which is hypothetical syllogism, because hypothetical syllogism is sort of more of a transformation rule, and less of a breaking things apart or putting things together. But it is possible that your conclusion is a conditional, um, and in a situation like that, especially if the conditional isn't together in the premises, very likely that you'll be using hypothetical syllogism at the end. So just wanted to put that out there that, remember hypothetical syllogism is a rule too. Um, so at the end here, I just want to work through some proofs and some examples of putting all these strategies to work, and that'll be it for the day. So I've got sort of 4 examples to work through. Here's 2 of them, and you'll notice that each of these examples will sort of deal with a different sort of situation. So the first premise here, or excuse me, the first proof here has a situation where the conclusion is just a simple sentence. So in this case, you're just going to try to derive E, and so chances are that's going to use a breaking apart rule, and you just have to kind of find where that's going to be in the premises, and in this case, it's in premise 3. So in order to get this conclusion, you need to break apart this conditional, right? So using our knowledge of main connectives, it should be obvious that this is the main connective, this arrow. So in order to break apart an arrow, you need either modus ponens or modus tollens. In this case, what we're trying to get is the consequent, so that's going to be modus ponens. And then everything else here is just to kind of note the other premises here. Here we have another conditional for premise 1, and so that we'll be using either modus ponens or modus tollens on that. And then here is a conjunction for premise 2, so we'll be using simplification on that. So just to kind of go through the proof. So it's always good form to start with simplifications. Those are usually the ones that you could do right away because it doesn't require any other letters to work. So the first thing we'll do is simplify line 2. It gives us not B and the other half, which is this more complicated thing. But nevertheless, there it is. I'm going to go ahead here and simplify 5 because that is also a conjunction. And in this case, I'm just going to simplify one part of it because I only need one part of it. I already know how to do this proof. So it's not wrong to simplify both, but it's just unnecessary. I won't need C. So let's see, I've got not B now, and not D. Those are negations. Those negations are helpful for some patterns. One of those patterns is modus tollens, and now 1 and 4 fit the modus tollens pattern, right? So I have this conditional, A, arrow B, I have the negation of the consequent, so I can use that to get the negation of the antecedent. So there's 1 and 4 modus tollens. And then now what I'm going to do is put things together in order to get the antecedent of the conditional in line 3. So what I'm trying to do here is to get that modus ponens pattern running. And in order to do that, I need to get this whole antecedent that's in the parentheses. So to get that, all I need to do is put line 4 and line 7 and 6 together with conjunctions. So let's see. So here's line 7, and here is line 6. So 6 and 7 conjunction. And now I have that antecedent. So once I have this entire antecedent from line 3, then I can do that modus ponens, and that gets me E. That gets me the conclusion. So there it is. So here's a situation where the conclusion was just very simple, and it was just a matter of breaking apart line 3 in order to get it. Okay, so let's move on to this other example. So here's a situation where our conclusion, looking at our conclusion first, our conclusion is a conjunction. So the strategy here is probably to get not C by itself somewhere, get not D by itself somewhere, and then our final move will just be conjunction. So I'll just kind of put that right away here. So our last move is going to look like this, where we get the conclusion through conjunction. So I don't know where that is yet in terms of numbers, so I'll wait to add that to the justification, but that's going to be where things go. Okay, so looking at the other sentences here, we've got not A and not B, so that's a conjunction. I'm going to break that apart. Then we have C arrow A and D arrow B. So I'll probably be using modus ponens or modus tollens to break that apart. And in this case, it'll be modus tollens, right? So I'll be using the negations to get a negation, right? So I'll get not C, which is something that I need, and then I'll get not D, which is the other thing that I need, and then I'll put them together. But modus tollens requires an extra line, and so I'll need to break up premise 1 first in order to get those other pieces. So here's nice simplification beginnings. So you simplify line 1 to get not A, simplify line 1 to get not B, and then those become the things that you use with these two conditionals to do the modus tollens rules. So 2 and 4, you'll do a modus tollens to get not C. And then 3 and 5 will be another modus tollens to get not D. And then we're already done. We just put those two things together with conjunction, so 6 and 7, and that gets us the conclusion. So that one worked pretty nicely. All right, so the final slide here, we've got 2 more examples, and I must be getting tired because both of these examples have errors in them, so we have to rectify that somehow. So I'll just do it here in the narration. In both of these, I put disjunctions where there should have been conjunctions. So in this first example, this or here should be an and in the second example, this or here should be an and. So just the proofs don't work if those are ors. Okay, so now that we have that fixed, we can go ahead and do these proofs. So first example here, note that the conclusion is a disjunction, and one of the disjuncts, the F, doesn't appear anywhere in the premises. So that is probably going to just come from addition. So remember that if you have something, you can add anything to it as long as you use a disjunction. And in this case, if we have not B, then we'll just be able to add or F to it at the very end. So the goal now is just to get not B, and that's going to come by breaking up a bunch of stuff in these premises. So we've got an and that could be broken up with simplification. We've got an arrow that could be broken up with modus ponens or modus tollens. We've got an or that could be broken up with disjunctive syllogism. And then we have, once we break those up, we'll have more things to break up. Here's an arrow that could be broken up with modus ponens or modus tollens. In this case, it'll probably modus tollens. So we can get a not B. And then this is a conjunction now, and that could be broken up with simplification. So where do we start? Well, one of our premises is a conjunction, so it's always best to start there. In this case, I can break up the conjunction to get D by itself and get E by itself. I only need D, so I'll just do it once. So I'm going to break that up to get D, and then D is going to help me to break up premise 2. So 2 is D arrow a bunch of stuff. So by use of modus ponens, I can get a bunch of stuff, right, and get that conjunction, which is 2 and 4 modus ponens. So okay, I have this conjunction. I'm going to break that up too. I need both conjuncts. I need the not A and the not C. So I'll break them both apart. So that's simplifying line 5. And so I'm going to use the not A to break up, or the first step of breaking up one, which is disjunctive syllogism. So not A or a bunch of stuff, or excuse me, A or a bunch of stuff, so not A, so therefore a bunch of stuff, which is B arrow C. So that's 1 and 6 disjunctive syllogism. And then I'm going to use the not C along with 8 to get not B. Oops, I already have it written down here. So not B comes from 8 and 7 modus tollens. So modus tollens gets me not B, and then as I mentioned before, we just add F to it, and that's just adding something to line 9. So there we have it. Working a little bit backwards, paying attention to the main connectives and knowing the rules allows us to do this. Okay, so we're going to end with a use of hypothetical syllogisms. So here's our conclusion. It's a conditional. Pieces of the conditional are in the premises, but not the whole thing. So what we're going to do here is hypothetical syllogism. So somewhere we're going to be able to get B arrow D through hypothetical syllogism. So again, just looking at the premises, we've got an or that could be broken up with disjunctive syllogism, another or that could be broken up with disjunctive syllogism, and an and that could be broken up with simplification. So we'll start there. So we'll simplify line 3 to get not A, and to get not B, so we'll simplify both because we need both. And so that will let us do our destructive syllogisms on line 1 and 2. So line 1 will be broken up using not A. So not A gets us the other stuff, B arrow C through destructive syllogism, so that's 1 and 4, destructive syllogism. And then with 2 and 5, we'll do destructive syllogism again to get C arrow D. And then those are the two conditionals that we would need to do hypothetical syllogism, right? So here's B arrow C, here's C arrow D, so the C's match up here in the chain, so that lets you get the first thing and the last thing. So B arrow D through hypothetical syllogism. So that's line 6 and 7 being transformed into hypothetical syllogism. So I hope this helped. If you have any questions, please feel free to sort of email me, and we will see these again when it comes time for the exam. So good luck, and talk to you later.